Welcome back to the Custom Corner. Today we're pushing a 0.4mm nozzle to its limits to see just how much detail we can squeeze out of a miniature print. I'll be walking you through exactly which settings to change, why they matter, and spoiler alert, why more optimization doesn't always mean better results. 4 prints, 1 ogre, let's get into it. Our test subject is this ogre from the Wasteland, a Kickstarter I ran a few years back. Full post-apocalyptic tabletop set, designed for 3D printing. Seemed only fair to put my own model through the ringer. For this first print, we're keeping our hands off the settings entirely. Stock profile, no tweaks. This gives us a true baseline to measure our improvements against. Let's slice it, and immediately I realized I needed to turn on supports. I also see there's a manifold edges error. This just means the model has some geometry issues, small gaps or inverted faces. Bambu Studio can usually fix this automatically, so we'll let it do its thing. Reslicing with supports, and we land at 1 hour, 21 minutes. That's our baseline. Fast, but let's see what the quality looks like. And here's our baseline print. This is great for a draft test. You can tell it's an ogre, but look at the layer lines, especially on the curved surfaces. The face, the shoulders, anywhere the geometry slopes, you can see the stair-stepping. Details are muddy, it's fine, but we can do better. Let's bump things up, switching from the standard profile to the 0.12mm high quality preset. This is a good starting point, but we're going to push it even further. First up, layer height. Dropping this to 0.08mm. This is the Z-axis resolution, basically how tall each step is. Thinner layers mean smoother curves and better detail on organic shapes like faces and muscles. The trade-off? More layers means more time. And this is going to be the main driver of our details. Flipping on the advanced toggle to show more settings here. Now, line width. I'm dropping the outer wall and top surface down to 0.35mm. These are the visible surfaces. Thinner extrusion lines can trace finer details more accurately. Think of it like drawing with a fine-tip pen versus a marker. Inner walls and infill stay wider since nobody sees those anyway. Next up, speed settings. Outer wall down to 30mm per second. This is where detail lives, so we want the printer taking its time here. Slower movement means less vibration, less ringing artifacts, and more time for each layer to cool before the nozzle comes back around. Inner walls can stay faster at 70. These are hidden inside the model, so precision matters less. Top surface speed down to 35. These are visible on things like shoulders, the top of the helmet, and the shield, anywhere that faces the ceiling. We want those smooth. Moving on, we're going to change the support Z distance, top and bottom, bumping from 0.12 to 0.2mm. This is the gap between your supports and the actual model. Too close and the supports fuse to your print, too far and the overhangs droop before they make contact. 0.2mm is a solid middle ground for clean removal. Now we jump to filament settings. That's the 3-dot menu here, then edit. Scrolling down to print temperature, and I'm dropping the other layers temp from 220 down to 205. Why cooler? Well, hotter plastic is runnier, more ooze, more stringing. Miniatures have a lot of travel moves jumping between small features, so we want the plastic behaving itself. Just don't go too cold or you'll lose layer adhesion. Quick note, my screen recording didn't capture a pop-up window for this step, so I had to re-record a few of these sections, just in case the view seems to jump around, that's why. Onto the cooling tab. Min fan threshold up to 90%, max to 100%. We want aggressive cooling on minis. Small features get revisited quickly, and if the previous layer hasn't solidified, you get blobby mush instead of detail. Layer time threshold set to 10 seconds. This means if a layer would print faster than 10 seconds, the printer slows down to give it cooling time. It's critical for tiny features like the horns or fingers and weapon tips. Minimum print speed at 15mm per second. This is the floor, the slowest the printer will go when it's trying to hit that layer time threshold. Important note, leave the first layer fan speed at 0. You need that heat to get proper bed adhesion. Cranking the fan on layer 1 is a great way to watch your print pop off the bed mid-print. Let's slice in 3 hours, 56 minutes. Alright, Model printing time is 3:27. The rest is time-lapse calculation, apparently deciding to join the party here. That's basically triple our baseline time. Let's see if it's worth it. Here's where it gets good. First up, the front view. Look at the ammo belt. On the baseline, you can see layer lines across every round. On print 2, the tops are smooth. Individual bullets, not layered cylinders. The shield is where this really shows off. On print 2, you can actually see the wood grain texture, not layer lines pretending to be wood grain. The chips and damage in the shield read as intentional detail now. The decorations and bolts are crisp and distinct. Top surfaces, the head, shoulders, and top of the shield, almost perfectly smooth on print 2. The baseline looks like a topographic map. In the back shot, the shoulders on the baseline are just stacked layer lines. On print 2, smooth, organic curves. That's what 0.08mm layer height buys you. Now let's see if we can push it even further. Switching the wall generator to Arachne. This is designed to handle variable thickness walls better and potentially capture finer detail. Also switching wall order from inner-outer to outer-inner. The theory here is that printing the outer wall first against open air gives better dimensional accuracy on visible surfaces. Now let's slice it. I'm looking at 3 hours 48 minutes total. Model time is 3:18. Actually a bit faster than the previous. Let's see if the quality holds up. And this is where the plot twist happens. Front view of all three. Print 3, our more optimized version, actually shows more visible layer lines. Look at the loincloth, then the beard. There's lines on the shield edge that weren't there before. Some weird artifacts on the chest as well. And if you look at the helmet, there's a lot of stringing there. Quick note, the damage on the ammo belt, that was me. Got a little aggressive removing supports. Print quality did nothing wrong there, that's just operator error. Side view with the hammer, there's some stringing on the ears, more visible layer lines on the hammerhead, and some stringing on top. Lines on the hand that print 2 didn't have as well. The back is pretty similar like the second print, except the back of the head has more layer lines on print 3. And the layer lines across the back look deeper, almost offset. Could be slight over or under extrusion from the setting changes. So here's the lesson. Arachne and outer first walls are great tools, but they're not universally better. For a model that was already printing well with standard settings, they actually introduced the issues. More optimization isn't always better optimization. At this point, I've got a nearly 4-hour print for what's essentially a tabletop mini. That's perfectly fine for instances where you want the highest quality for a single print. If you're looking to generate a number of them though, then you'd want to find a middle ground. Good quality at a reasonable print time. Let's target around 2.5 hours. Switching to the 0.16mm high quality profile as our starting point. Reslicing and no change. Right, because I'm still at 0.08 layer height. Let's try 0.14 and reslice. Now we're looking at 2 hours 20 minutes. Getting closer. At 0.12mm, we got 2 hours and 44 minutes. Slightly over target. 0.13, we got 2 hours 34 minutes. Close enough, let's print it. Here's our compromise print. And yeah, you can see we gave something up. You can see layer lines visible on the shoulder and the top of the helmet. On the front view, there's lines on the chest, shield, and hammer, and some detail loss on the face. Though interestingly, there's less stringing than print 3. On the side view, you got layer lines are definitely there on the shoulder, back, helmet, and arm, and even on top of the shoe a little bit. Back shot, all the curved top surfaces show their stair-stepping again. Not too bad, not as bad as the base model, but still there. The lower back isn't bad, but anything facing upward took a hit. Here's a side-by-side. Baseline on the left, compromise in the middle, and the best quality on the right. You can see the progression clearly. Compromise print is noticeably better than the baseline though. Details are sharper, surface is cleaner, but it doesn't touch that 0.08mm print. The difference between 90 minutes and 4 hours shows. All 4 prints in order. 1 hour 21, 3:56, 3:48, and 2:34. So what did we learn? Layer height is king for miniature detail. but it costs you in time. Line width and speed settings make a real difference on visible surfaces. Cooling is critical for small features, and sometimes more advanced settings like Arachne and outer first walls can actually make things worse if the model was already printing well with standard settings. There's no single perfect profile. It depends on whether you're printing display pieces or tabletop armies, how much time you have, and how much post-processing you're willing to do. If you got settings I missed, or spotted something I did wrong, drop it in the comments. Always looking to learn. And don't forget to hit that subscribe button. Thanks for sharing this journey with me. See you next time on the Custom Corner.